Okay, let's go ahead and get started with our lesson today. Our lesson is 3.3 slopes of lines. So our I can statement for today is I can find slopes of lines and I can use slopes to identify parallel and perpendicular lines. So vocabulary we're going to be talking about today is slope. Right here are our first four different categories of slope. So on this first slope, you can kind of see how this is a positive slope. We have a line that is going uphill. So the next one here is a negative slope, so it's kind of going downhill. Next one there is zero slope kind of just goes straight across, has no upwards or downwards movement. And undefined slope, this is going to be a straight vertical line. So a really good way to kind of be able to keep these in mind, trying to figure out which one's positive, negative, zero, and undefined, is to think of if we had kind of like a little stick character or something like this on each slope. As you can see, if you were this character on a positive slope there, you would be going uphill. So positive slopes are uphill. If we have a negative slope, if we are this little slope man, this is going to be downhill. Okay, so every time that we have a line that goes down, we are going to have a negative slope. Zero slope. This would be kind of like if we were just walking on a flat surface, on a flat ground. There would be no slope. Okay, so think of putting yourself on that line. You're not going up, you're not going down. There is zero slope here. Now, over here, undefined slope. You can kind of think of undefined slope as it's not possible. Okay, it's not possible to walk on there. This guy right here, if this was us, would be falling off of this line just because it's not possible to walk on this slope. So undefined slope, straight up and down line. Anytime that we have a slope, let's say, for example, our slope was 7/0, that would be considered an undefined slope. So anytime we have 0 in our denominator of our slope, it's going to be undefined. All right, let's get into a couple of examples here. So first example here is we have to find the slope of the line. So there's a certain formula that we are going to use to find the slope of the line, and that formula is we're going to say m. M is actually the letter we use for slope, is equal to y2 minus y1 over x2 minus x1. Y2 minus y1 over x2 minus x1. You can kind of think of this as rise over run. So I know rise kind of sounds like wise. So that's how I always remember the y goes on top because we have our rise over our run, and y sounds like rise. Those two words rhyme there. So let's go ahead and get started here. So s appears to be -3, -3, +7. -3, +7. And then t down here is going to be -1, negative. All right, so these are our points here. I am going to go ahead and write these points down. So s we said was -3, 7, and t we said was -1, -1. So these are our points here. I'm going to go ahead and label our points. That's a big thing that we want to do. Just like we did with distance and midpoint, we're going to label these x1, y1, and x2, y2. This is going to help us keep track for our formula here. And from this point here, we're just going to go ahead and fill out our formula. So m is equal to -1 minus 7, y2 minus y1. X2 minus x1. X2 is -1 minus x1. Well, x1 is a -3. So -1 minus a -3. We can look at that as -1 plus 3. All right, so that's how we're going to look at that. So this is going to be m is equal to -1 minus 7 gives us -8, and -1 plus 3 is going to give us a +2. One step left here, -8 divided by 2, and as you can tell here, that is going to be a -4, and we could clearly tell from the beginning that this slope was going to be negative, right? If we had a little guy on here, this guy would be going downhill. So we knew from the start it would be negative. After using our formula, our rise over our run formula, we found that this slope was -4. All right, let's do another one here. So we're trying to find the slope of this line. Well, if you guys remember back to our definitions here, we can kind of already tell what's going on with this line. If we had a guy that was walking on here, he would definitely be falling off. So I already have a really good idea as to what type of line this is going to be. But let's go ahead and use the formula here just to show what this looks like. So this is going to be 0, 4. Over here, this is going to be 0, -3. All right, so our formula again is rise over run, or y2 minus y1 over x2 minus x1. So here are our points. Our points are P, 0, 4, and Q, 0, -3. Again, I want to label these points x1, y1, x2, y2. So y2 minus y1, this is going to be -3 minus 4. And x2 minus x1, well, both of our x's are zeros. So this is going to be 0 minus 0. Now, we're going to do -3 minus 4, which is -7. 0 minus 0, which is 0. So we talked a bit about this a little bit already, but anytime we have 0 in the denominator, that tells us that this is going to be what we call undefined. Okay, so if you tried to put this in your calculator, you should get an error. We cannot divide anything by 0. So anytime we do have 0 in the denominator, we will say that our slope is undefined. And again, we should have already known that just by looking at this line, seeing that it goes straight up and down. But this is how we know for sure that it's undefined. All right, next example here, we got G, we've got F. If we want to kind of predict what this slope is, I would probably say that this is going to be a positive slope, just judging by the fact that it goes uphill. So let's go ahead and write down our points here. So G is, looks like -2, -5, -2, -5, and F. Looks like F is 6, 2. So these are our 2 points here. Again, go ahead and pause this from this point. I want you guys to get some practice at using the slope formula. So go ahead and do this. I'll meet back with you up when you are finished. Okay, so slope here. We got x1, y1, x2, y2. It's always the first thing we want to do after we write down our points. Now let's go and plug this into our formula. So 2 y1 minus y1, or y2 minus y1 is going to be 2 minus a -5. So negative minus a negative, we're going to turn that to a plus. 2 plus 5, x2 minus x1 is going to be the same thing. There's 6 minus a -2, or 6 plus 2. So we got to make sure we are understanding of those double negatives there and why we can turn those to plus signs. 2 plus 5 is going to give us 7. And 6 plus 2 is going to give us 8. So we will say here that our slope is 7/8. And just to show you guys exactly what this means, when we say the rise over the run, that really means a slope of 7/8. That really means that we are going up 7. 1, 2, 3, 4, 5, 6, 7. Up 7. And running 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we are rising 7 and we are running 8. That's what this rise over run means. So yes, we can use this to find the slope if you have 2 points that are on the same coordinate plane. So instead of doing the slope formula here, we could have just counted up 7 and over 8. But remember, we always have to reduce after we got that. So for example, if we had, let's say, 6/2, we would then reduce that to a slope of 3. All right, finding the slope here of this line. Again, I think we have a pretty good idea as to what this slope is going to be, just based off of the information we've gone over so far. We will use the formula here to figure this out. So y2 minus y1 over x2 minus x1. Our x here is going to be -2, -1. And our y is going to be 1, 2, 3, 4, 5, 6, -1. So there is our x and there is our y. Again, start this off with x1, y1, x2, y2. So this is going to be y2 minus y1 here. So -1 minus a -1. So we're going to turn that to a plus. X2 minus x1, 6 minus a -2. So minus a negative. So this is going to be -1 plus 1 is 0. 6 plus 2 is 8. So 0 divided by 8 here, obviously 0 divided by anything is always going to be 0. So we have a slope of 0, which again, I think you guys could already tell just judging off of our line. So we have little guy here. Little guy's not going up. He's not going down. So that would be a no slope. All right. So again, we could use the formula for this. So go ahead and pause this. I want you to get some practice in it using this. Once you finish, go ahead and continue the video. So I'm going to use our formula here, y2 minus y1 over x2 minus x1. We actually have the points written out for us this time. So we can go ahead and just say x1, y1, x2, y2. So now we are going to say here m is equal to y2 minus y1. So -4 minus 6. x2 minus x1 would be 5 minus a -3. So since we have a negative, we're going to turn that to a positive. So here, -4 minus 6, that gives us a -10. 5 plus 3, that's going to give us a positive 8. So -10 over 8, I can tell here, since these are both even, that this does in fact reduce. So I'm going to divide both of these here by 2, and this is going to give me a final answer here of -5 over 4. So our slope, or our rise over run, is -5 over 4. All right, almost done here. Got 3 slides left. Some things we need to talk about. The slope of parallel lines. The slope of parallel lines. Anytime we have 2 lines that are parallel, that means they are going to go forever and ever in the same direction, but they will not intersect. So basically, we could have 2 lines like this. They would go on forever and ever, and they would never intersect. The slopes of these lines are equal. Okay, the slopes of these lines are equal. So what I'm basically saying here is if this has a slope of 3, well, guess what? This also has a slope of 3. Okay, the slope of parallel lines have to be equal. There is no way around it. Slope of perpendicular lines. So you know that perpendicular lines look something like this, and they intersect at a right angle. So the slope of perpendicular lines are what we call negative reciprocals. Okay, negative reciprocals. So let me show you exactly what I mean by that. Let's say we had the slope 3/4. Okay, we have the slope 3/4. Well, the negative reciprocal of 3/4 is going to be this fraction flipped upside down with a negative sign in front of it. So we would say 4 over 3, and that would be negative. Okay, so that would be negative. So anytime we have a negative reciprocal, we're going to flip it and then make it negative. So what if we had, let's say, for example, what if we had a -5 slope? What would be the negative reciprocal of -5? So in this case, it's tough because this does not look like a fraction, but just know that anything divided by 1 is the same thing as itself. So -5 here divided by 1 would still be -5. So what we're going to say here is we're going to flip our imaginary fraction over. So this is going to be 1 over 5. And if I have to make this a negative reciprocal and it's already negative, all I'm going to do is I'm going to take that negative away. Okay, so this is going to be from -5 to a positive 1/5. These would be negative reciprocals. So let's go ahead and check out the last two questions here. This says determine whether FG and HJ are parallel, perpendicular, or neither. So FG would be these 2 points. So we need to find the slope of FG. So we're going to say FG here. And again, I'm going to write this formula up here for you. Y2 minus Y1, X2 minus X1. FG, these are our points, X1, Y1, X2, Y2. FG is going to be Y2 minus Y1, so -1 minus a -3, so negative, we're going to make that a positive sign there. X2 minus X1, -2 minus 1. All right, so here, I'm sorry, I should have an M over here. This should not be an FG. This should be M here for FG because we're finding the slope. We're not finding what FG is. So -1 plus 3 here is going to be a positive 2. -2 minus 1 here is going to be a -3. So our first slope is M is equal to 2 over -3. Now we need to find the slope for HJ. So HJ would be 4, 5, which is going to be our X1, Y1, and J is 7, 3, X2, Y2. So here we are going to say Y2 minus Y1, so Y2 is 3, minus Y1, which is 5. 3 minus 5. X2 minus X1, 7, minus X1, which is 4. So 3 minus 5 here. 3 minus 5 is going to be -2, and 7 minus 4 is going to be a positive 3. So our two answers here are M is equal to 2 over -3, and M is equal to -2 over 3. Now, some of you are saying, well, this denominator is negative over here, and the numerator is negative over here, so these are not the same. Well, yes, in fact, they are. This denominator being a negative still makes this whole thing negative. So just because the 3 is negative doesn't mean that the whole thing is a negative. We can still view this as a -2/3. Just like if we were to change this to a decimal, this would be -0.67. And same thing over here. If we wanted to change this to a decimal as well, this would still be -0.67, right? So just because one of the numerator or the denominator is negative doesn't mean that these are different. These are still, in fact, the same exact number. So since these are the same exact number, are these going to be parallel or perpendicular? Hopefully, you remember our definitions from the last page. These will be parallel lines. All right, parallel lines here. Last one. So we got A, B, and C, D, parallel, perpendicular, or neither. So first thing we got to do here is label our points, X1, Y1, and then X2, Y2. So let's go ahead and find the slope of AB. So Y2 minus Y1, 5 minus a -1. So since this is negative, we'll say 5 plus 1. X2 minus Y2, X2 minus X1, 4 minus a -2. So 4 plus 2. So this is going to be 6 over 6, which we are going to get a slope of 1. So the slope of AB is 1. Let's find the slope of CD. So X1, Y1, X2, Y2. Here, it's going to be Y2 minus Y1, -2 minus 1. And X2 minus X1, 9 minus 6. So here, -2 minus 1, that's a -3. And 9 minus 6 here, that's a positive 3. Now, this right here is going to be m is equal to negative 1 over 1. Now, the reason I wrote it like that is because over here, this is also technically 1 over 1, right? Now, notice the one on the right is negative. The one on the left is positive. If I asked you, give me the negative reciprocal of the m here that's on the left, our red m, the negative reciprocal of this would be negative 1 over 1. Well, that's what we have right here. Okay, so these are negative reciprocals, which means they will be perpendicular.